Hello again. So this video is going to be about Virp charts 7 and 10. Before we begin, just want to take a look at the packet really quick. By now you should have 1, 2, 3, 4, 5, and 6 done. 8 and 9 will be the two you're able to do afterwards. 11 is pretty intense. We would never ask anything as difficult as 11 for a test, but if you're up for the challenge, hey, by all means go for it. Alright, so let's take a look at number 7. So number 7 is a combined circuit. R1 is in series with everything, and R's 2 and 3, that's a parallel branch. The circuit, once current reaches right here, the circuit is going to have to choose between going through R2 and R3, and then the current will rejoin right here. So we're going to approach this first by saying, well, R2 and R3, what do these two do in terms of resistance? Since they're parallel, the 1 over R equivalent would be 1 over R2 plus 1 over R3. So that's going to give us 1 over 20 plus 1 over 60. 1 over 20 and 1 over 60 is 4 over 60. Again, you can use a calculator. I am just doing the mental math because it's faster this way. R equivalent would be 60 over 4 or 15 ohms. So what this tells us is that this whole branch of the circuit right here is actually going to be the equivalent of 15 ohms. It's almost in a sense what we could do is we could redraw the circuit and say, here's my power source, 120 volts. Here's R1, and instead of having that 2-3 parallel branch, I'm going to have 2-3 combined as a 15 ohm resistor. R1 is a 5 ohm resistor. Now it's just a matter of adding them like you would normally in series. So 5 plus 15 is 20 ohms. So the total resistance for the entire circuit is 20 ohms. Just like last time, I'm going to go ahead and delete all of this wonderful stuff about the resistances and how they're added up. By all means, pause the video and back it up if you need to still do that. So we have 20 ohms is the total resistance. Our other rules still apply. I have 2 in this column here. So V equals IR, P equals IV. First one, 120 equals I times 20. So I will be 6 amps. And then P equals IV. So P equals the 6 amps I just solved, 120 volts. That's 720 watts. All right. Current. So what we know based on this piece of information right here is that 6 amps leaves the battery. So 6 amps leaves the battery. It has nowhere to go other than through R1 until it reaches this intersection. Then I don't know what happens when it gets to 2 and 3, but it will rejoin and come back to the battery. So at the very least, I know that R1, that's 6 amps that goes through R1. Now that I know that R1 is 6 amps, what I can say is 6 times 5 is 30, so it consumes 30 volts. And 30 times 6 is going to be 180, so it's 180 watts. Now I go back to what I would do in a series circuit, and by that I mean I think about this line right here that has come out of the battery at 120 volts. I just saw that R1 consumes 30 volts, which means it has to bring down the voltage to 90. So all along this line here would be 90 volts. And our last line is always going to be 0 volts. So this last line here, coming from the negative terminal, the battery's at 0 volts. What this allows me to know is in between 2 and 3, resistors 2 and 3 take 90 volts and bring it down to 0 volts. So I can put a 90 here and a 90 here. To get the total current, 90 over 20, that's 4.5. 90 over 60, that's 1.5. Power, 90 times 4.5, that's going to be 405. 90 times 1.5, that's going to be 135. 180 plus 405 plus 135 is 720 watts. And I see here 720 watts created by the battery. This chart is good. Let's move on to the second one, number 10.